It is so easy to set up an agentic workflow locally and 100% free. You don't need to set up paid APIs and pay for tokens. All you need is your code editor, Ollama, and CrewAI to automate your daily tasks for 10 times more productivity and more accurate results. We will go through this 5-step process to set up our AI agents. First, we will install Ollama to use Mistral, which is a transformer-based model. You can choose any other model available on this Ollama models page, but transformer-based models such as Mistral are well known for their contextual precision. For the second step, we will set up a virtual environment with a specific Python version, and then configure this environment to work with Ollama. In the third step, we will install CrewAI and its tools needed for running agents. Then we make a project and set up 2 specific files to make a new local LLM based on the Mistral model. So later on we can connect it to our working environment where we will use CrewAI. Finally, we will make our AI agents and specify their tasks using the model that we made locally in the previous step. For this tutorial, we will follow the refinement method, but only with a single iteration to save time. The method is presented in this paper, which I've explained together with several other methods in my previous video. I will leave its link in the description box for you too. This method helps us to use the same language model to make multiple AI agents with different capabilities that complement each other and refine each other's responses. I will leave a link to all the code and the setup procedure so you can follow it at your own pace. Here's how to do it. First, I'm installing Ollama by copying its command from their website in my terminal. Once Ollama is installed, from Models, select Mistral. Then use pull or run commands to download it to your Ollama models like this. If you want, you can run the model by asking it some questions to see how it works. Next, in the VSCode, we are going to set up a virtual environment using Python 3.12 and give it a name. This will be a folder or directory in your working directory. Navigate to its bin directory with the cd command and then use the source of your environment to activate it like this. Once we have the virtual environment set up and ready, we should update this environment to point to the Ollama functionalities that we just installed. We do this step in this .env file by using OpenAI compatible free API endpoints, which helps with chat completions. The first part points to where Ollama runs in your local host. You should not change this. The second one specifies the LLM you want to work with, and the last is a formality key. Just save the .env file and close it. One more thing is left before we actually start our project, and that is to install CrewAI and its tools using pip install in your terminal. Now we can make a new project folder from the terminal using the mkdir command and navigate to the folder. Here we need to make 2 important files which help us make a local language model in our PC based on an Ollama model, for example Mistral. Using the nano command, make the first file, which is called model file, where you specify the LLM and set these 2 parameters exactly as you see here. You can lower the temperature to make the model more factual and ask the model to stop when results are obtained. The system message gives more direction to the behavior of the LLM, but you can leave it empty. Use Ctrl+X to save and exit. Now we need to make the second file, which is the shell script with the .sh extension that pulls all the information from the model file we just made and executes it. Again, use the nano command to open the editor. Here, specify the model you want to use, for example Mistral, and the name of the custom model or the local LLM you want to make on top of it, for example Mistral Crew. Then you instruct Ollama to pull this base model and create a new custom model based on it. Use the F flag to force enable deleting it, and then give the path to the model file you made previously in the same directory. Again, use Ctrl+X to save and exit. Now back in the terminal, we first make this script file executable using the chmod command and +x argument. Then we execute it. If it shows success without any error, it means you successfully made your custom local LLM. In my case, this is Mistral Crew. To check if that's the case, just use the Ollama list command and it should list this new model too. If you followed me so far, really all that is left is just to make a Python file to create our agents and put them to work. So again, use nano to make a Python file in the same project directory and give it a name. In the editor, I'm going to paste the code I've already prepared, but I'm going to explain it to you. Don't forget to check the link in the description box if you want to copy my file. First, we import some functionalities from CrewAI such as agent, task, and crew, as well as chat OpenAI from LangChain OpenAI. Since we have already configured our environment, we just set this API key to not applicable here. Then we specify our LLM and the endpoint where Ollama is running in our local host. This would be the same local host you previously added to the .env file. Now is the time to make as many agents as we need for our task. Here I only make 2 agents, one which does the research and the second one which refines the researcher's response and turns it into a technical report. Feel free to pause the video to read each agent's role, goal, and backstory or context. For example, for the researcher agent, I'm asking it to give a comprehensive analysis of recent AI opportunities for tech solopreneurs, and then repeat the same with more context for backstory. I'm setting allow delegation here to false to save time running the file for this video, but I recommend you to set it to true so you get the best out of the agentic concept, for example, collaborating on problem-solving tasks. But I'm setting verbose to true so you can see the agent's thought process and how it performs your tasks, and then I pass the LLM as specified before. Copy and paste the same lines for the second agent, but change its role and the context. For example, I'm asking it to refine the researcher's responses and then act as a professional writer to produce a technical report. Then we specify the number of tasks needed. Here I want each agent to just perform 1 task to save screen time for this tutorial. Use more details to set the task description and your desired output, and then specify which agent has to perform this task. All that is left is to turn the individual agents into a crew or team using Python list for agents and tasks, and then print the result. Here's how my crew performed. You can see their thought process in green and the final output in white. Pretty impressive for a relatively simple setup. The straightforward setup that I showed you in this tutorial is very versatile. You can make more agents and ask each agent to analyze and refine its previous agent in a response refine chain, which significantly increases the accuracy and relevance of the final response. If you decide to run a cool project with this setting, I'd love to know.